Even and odd numbers. What is an even number? List some examples of even numbers. Every even number is an integer that can be evenly divided by 2, a number whose last digit is 0, 2, 4, 6, or 8, a multiple of 2, and has a factor of 2. List some examples of even numbers. There are an infinite number of even numbers, including these: 2, -4, 248, -682, 2,508, -7,820. See how the last digit of all of these is one of these numbers here. What is an odd number? Every odd number is an integer that cannot be evenly divided by 2, a number whose last digit is 1, 3, 5, 7, or 9, all the numbers that are not multiples of 2, and numbers where 2 is not a factor. List some examples of odd numbers. Once again, there's an infinite amount of odd numbers, including these: -1, 3, -9, 149, 589, -2,897, 8,565, and so on. Let's use this number line to develop an understanding of even and odd numbers. The number line has breaks so that it spans from an infinitely small negative number m to an infinitely large positive number n. Generally, we use n to represent any integer. In this case, we use m and n just to be clear that they are different integers. The symbol for a break in the axis or the number line are these two lines like this. Any integer which is multiplied by 2 becomes an even number. It doesn't matter if the original number is even or odd. This is because once you multiply any number by 2, it automatically now has a factor of 2 and is therefore also a multiple of 2. That is shown on the next slide. So if you take any number and multiply it by 2, you get even numbers. So 0 by 2 is still 0. 1 multiplied by 2 is 2. 2 by 2 is 4. 3 by 2 is 6. And so on. N times 2 is 2n. M times 2 is 2m. The general formula for an even number is 2n, where n represents any integer. Adding 1 to any even number will generate the odd numbers. So if you take 0 and add 1, you get 1. Take 2 and add 1, you get 3, and so on. Therefore, the general formula for any odd number is 2n plus 1, where n represents any integer. Even numbers are closed for addition, meaning that adding two even numbers yields an even number. That can be seen by the following use of the distributive property of multiplication, where m and n are arbitrary integers and therefore 2m and 2n are arbitrary even integers. Add any two even integers and then use the distributive property. So we're going to factor that 2 out. The expression in parentheses m plus n is an integer, since integers added together result in an integer. The result of this is even, since multiplying any integer by 2 results in an even integer. So therefore, the sum of any two even numbers is an even number. Multiplying any number, even or odd, by an even number yields an even number. Using m and n to represent any two integers, then 2m will be even, because any integer multiplied by 2 is even, and n can be either even or odd. So multiplying them together is 2m times n, but we can regroup under the associative property. So we can say, all right, well, that's 2 times m times n, and look, now we can group these together. The expression in parentheses is an integer, since integers multiplied together result in an integer. When that expression is multiplied by 2, the result is going to be an even number. Therefore, the product of any number and an even number is even. The result of adding odd numbers depends on how many odd numbers are added. Each time an odd number is added, plus 1 is added, since each odd number can be represented as 2n plus 1. If 2 odd numbers are added, a total of plus 2 is added, yielding an even number. However, if 3 are added, a total of plus 3 is added, which is the same as plus 2 plus 1, therefore yielding an odd number. So, adding an even number of odd numbers together yields an even number, and adding an odd number of odd numbers together yields an odd number. Since multiplication is repeated addition, the same pattern emerges when multiplying odd numbers together. When odd numbers are multiplied together, the result is an odd number, since that's the same as adding an odd number of odd numbers together. So 3 times 5 is the same as 3 plus 3 plus 3 plus 3 plus 3, which is 15. This could also be represented as adding 3 groups of 5. 5 plus 5 plus 5 is 15. So an odd number of odd numbers are added together. Odd numbers multiplied together yield an odd number. So, in summary, the sum of even numbers is an even number. The product of an even number and any integer, even or odd, is an even number. The product of only odd numbers is an odd number. The sum of an odd number of odd numbers is an odd number. And the sum of an even number of odd numbers is an even number. All this follows from these general forms. Even numbers are 2n, odd numbers are 2n plus 1.